Good morning. Good morning. I want to talk about soldering. As someone who spent a lot of time not being able to solder and having extreme difficulty soldering, and then suddenly being able to solder through some unknown means, and lately I've been spending a lot of time looking in the microscope, doing surface mount soldering. So hopefully I can be of assistance. Soldering. This is not your regular soldering tutorial. This is theory and instruction, information. Because soldering is one of those things I've been thinking about. It's one of those things that is reliant very heavily upon your understanding of the process and equipment that you're using in the process. And I, possibly like many, suffered heavily by using someone else's equipment the first time and seeing, oh, this is easy. You touch the thing to the thing, and you touch the other thing, and then that's it. It's soldered. It's perfect. This is very much not the case. Soldering is dependent upon... soldering is basically welding, actually. So you need to have the right... You'd have good temperatures on the things, good contact between the things, and good purity in the contact, or purity in the welding process. So when you pick up a soldering iron from someone else's station and use that soldering iron on that kit, whatever it is, with that tip, with that solder, and which might contain that flux, everything works very well. But if you don't know that you just partook in a multi-part experience, that it was not simply your skill applied to jabbing the iron in the general direction of the joint you're trying to make and then adding the solder, if you're unaware that there was support apparatus around you and care and preparation and maintenance, then you might be confused, or you might be excused for thinking that the process is very easy. In order to solder, you must have two surfaces of an appropriate temperature, of a good enough temperature to melt whatever the solder is that you're using. The surfaces must be clean and clear and have equal heat applied to them. And you cannot do that if your tip is bad, if your tip is oxidized, if you're not transmitting heat properly, if you don't have appropriate physical contact between the two components. If one is cooler than the other, that's not going to work. And certainly if the iron is much hotter than the item, then that's not going to work. The solder will flow the wrong direction. So we have had, I've been doing a lot of card repair, which is surface mount soldering under a microscope, and you get to see a lot when you look at it with a microscope, because you see more of the characteristics of the solder, and switching between different types of solder, the leaded and the unleaded, and using flux versus not using flux. All that stuff makes a serious difference, and a difference that you can see under the microscope very clearly. And if you watch, you might also be quite frustrated by these tutorials that you might find online, and it's just like, yeah, if you want to if you want to solder this QFN component down, all you do is you cover the area with flux, you gently toss the QFN part near the footprint, you turn on the hot air, and then the part goes which is exactly what happens in the absolute best case scenario when the stars align perfectly. Or when you understand the temperatures that you need, understand all the settings of all your tools that you need, understand how long something has to be under heat, understand what is the proper flux to use and what is the proper solder to use, and then you're basically it's the old talk show thing. It's like, here's how you bake a cake. You do these things, you mix these things together, and I've already got one prepared that's complete. You're watching the completion part. It's like the step 10 is turn on the heat and put the part on, turn on the heat, and then it works. So identifying when PCBs are dirty, when the pads are different, when one of the pads is sinking heat, when your tip is not performing properly, when your tip is getting oxidized or needs to be retinned or needs to be thrown out. All of these things, identifying all of these things is how you get good at soldering. Understanding when things are not right, or when things are behaving strangely, and then addressing the issues that are causing that. That's how you solder, actually. Soldering is not a process. Is not the process of touching a heating element to two metals and then adding some solder to it, adding some tin and lead to it. It's very much a process. So if you have pads that are dirty, your solder is going to look ugly. Your solder is not going to be shiny. I think the solder kind of absorbs that stuff and it changes how it flows, but it looks like clay, and it gets sticky, and it looks weird. It starts behaving strangely. And when something like that happens, I love to grab the heavily fluxed leaded solder and just melt it over the whole area, just kind of make a pool of it, and then wipe it away with the soldering iron. And doing that seems to pick up all the gunk, whatever's on there, because suddenly the solder is all shiny, and all the pads take the solder very easily. Because there's little, even if you change, we changed surface coatings, and immediately I was like, what's wrong with this? Like, this solder's wrong, or the boards are dirty, or my temperature is wrong, or the tip is bad. Something's wrong here, because it's not doing what it did yesterday. And then you have to adjust the setup for that, which is actually quite the same with any kind of welding. It's like, okay, what you can grab a book from the 70s that says, if you're doing this metal and this metal, this is what you need to use. This is your feed rate for gas and and your speed and your wire rate. You do the research, and then, hey, look, here's the answer. And then you do the answer, and it works. Surprise. And it might be a function of autodidacts. It's like you go on YouTube and learn something, and you need to understand that what you're getting is not a complete set of knowledge about it. What you're getting is like the starters portion of it. That said, solder, there are good soldering tutorials, but it's a lot cooler to watch the solder just flow perfectly. To watch someone just grab a part that's covered in, a regular surface part that's covered in, guy's legs right next to each other, throw solder on it so it's just like a giant blob, and then they're like, and then you just brush with the solder tip, and the solder tip goes bloop, and wipes off all the excess solder and leaves none of the wipes off all the excess solder and leaves all the legs perfectly connected, not shorted, with minimal solder on it. Because it's like a surface tension thing. You if the solder is of good quality and you have good contacts, and flux is a big thing for that. The soldering iron tip and that heat sink of a blob of solder will absorb that other solder, and it'll pull away anything that it can pull away, because otherwise you're going to get, it'll pull away what it can pull away, except for the stuff that's between contacts. So it's a great way to do it if the situation is right. I have I've done that with QFN parts before. It's not fun hand soldering QFN parts, and there's, I don't know, like best case scenario, I still had like a 5 or 10% failure rate. Like it's just some solder got under the part and it was not coming out. Like that's it, the end. So there's a lot of things that are possible, but understanding that where the solder flows and how the solder flows, having the experience of watching your tip take the solder properly, and then realizing then that when your tip is not taking the solder properly, when you've got a tip that's conical, or you've got a tip that has a lot of surface area, and you apply solder to it, and the solder just blobs into one bead on like the bottom left hand corner of it, and it stays there. Like it's supposed to coat over the whole thing evenly, but if that is what's happening, you're not getting good heat transmission. You're not conducting heat through the tip well enough, and it's basically like a hot spot, which means you need to re-tin the tip, resurface the tip. Maybe I don't know if that's a thing. Like the tips are actually rather sensitive, and if you leave it on for a long time, it'll pick up oxidation, it'll degrade. There's coatings that are on them that if you like I did this, I was guilty of this. I took sandpaper to my original soldering iron because I'm like, the tip is not working. There's no like the heat is sticking on like a blob on the top of it, and I'm trying to touch that blob to the other thing to transfer heat to it, because you have to transfer heat to the parts, not the part, the parts first. And if you have a PCB, you need to make sure that ground plane or whatever the pad is has heat transfer to it, and you need to have that contact before you apply solder to everything. So if you're not transmitting heat through your tip, congratulations, you're not soldering, and it might look as though you are, but you're really not. It's not going to happen. So it's more like seeing when things are wrong. And I never used any kind of flux. I'm guessing what I did was I wound up getting some high flux leaded, rosin core solder, and I changed up the solder, and then I gotta say that I changed the tip. I can't imagine that the same tip worked, but I could be wrong. And I used a dumb soldering iron. It didn't have any settings on it, no temperature control. It was just on and off. And of course I left it on all the time, so I didn't know what I was doing. So I think it was cranked up so high, and the elements that I was heating were so small that it transferred enough heat to those elements, so that when I applied solder to it, the solder took to those elements rather than taking to the tip. So it was perhaps an inefficient way of soldering, but it I seriously got to a point where I couldn't make bad solder joints. Like I was trying to make one as an example, like a cold joint or something like that, and I could not make it happen. And thinking about knowing what I know now, I'm guessing the tip was heavily oxidized and wouldn't take any solder, but it would still transfer heat, kind of badly, but it would still do it. And that's all that's really necessary. You're transferring heat. That's the goal. The goal is to heat the elements that you want soldered together. And then once those are heated, apply solder to them such that you are welding those pieces together with a clean contact. And that idea that you have two surfaces and you're going to bridge them with some molten metal, you need to understand that those surfaces need to be cleaned where they are. And that's where kind of the flux comes in. And you can have, really smelly, nasty solder that works fantastically. And you can have really nice, clean, expensive solder that works terribly. It just kind of means you need to have more prep work going into it beforehand. But absolutely, if you are having trouble soldering, I would say first buy a new tip, or whatever your soldering iron is. Just buy a new tip, because I used an inexpensive, like a $30 soldering iron for a very long time, and I used the same tip, and that was the same tip that I was like, oh, this isn't working right. I need to re-tin my tip, and I don't have anything to do it. I didn't even know what re-tinning was. I'm like, there's gunk on here. I'm gonna get it off. Sandpaper, go. And that was all that I did. So there's a lot of care and feeding that I didn't know about, but the point is that you can make do with inexpensive stuff as long as you understand that there are certain things that must be maintained. And frankly, the only thing that needs to be maintained to accomplish soldering is that the two elements be heated, and then solder be melted onto both of them, and that's about it. You know, at least close enough that the solder will connect between those two pieces. And I've seen joints that look really bad. They look like cold joints, or they look dull, and they conduct just fine. They're probably not. They're certainly not ideal, but you know, I still have, I think, one of my old Altoid tin projects. It was probably my first successful soldering project. And those joints look horrific. They're terrible. But they did work. So yes, first get a new tip for your soldering iron, or if you hate it and you want to just start over, you can buy a new one, or buy another $20 soldering iron. It's not that difficult. You can use these things. You don't need a $300 kit or $100 kit in order to actually solder. You just need a better understanding of the interchange that's happening between the metals and the third metal you're introducing, the surfaces, and heat. And that's really about it, actually. So understanding those things, you can adjust to work with your equipment, whatever that equipment is. So definitely try a new tip or a new iron, and definitely try different solder. In fact, I might even recommend trying a few different kinds of solder, to seeing what works well with your iron, or what works well for how you do the soldering that you do. But the caveat, you know, the one thing you must always keep in mind is the two elements must be heated. If they are not heated, the solder will only adhere to one element, and it will not weld to the other element. Or worse, it'll give you a cold joint, or just kind of a barely bridged connection, so that it tests okay and it seems to work, but over time gunk is going to build up on it, or it's just gonna be a flaky connection. So that's how you solder. I didn't really expect this to be a soldering tutorial, although I guess it's more about soldering theory. But that's what you do. There are a lot of things that are 100%, skill, 100% technique, and very small portion of it is your equipment. But in this case, it very much is the equipment. You're working with your ability, you're working with your equipment, and you're working with your metals, the materials, the contact surfaces that you're working with. And as soon as you realize that, soldering will become very, very easy.